everyone, I am Janapati Srinu. Who are watching first time my video, subscribe my channel and share to your friends. In previous video, we discussed about coordination chemistry, basic concept like nomenclature, oxidation state, and how to find out the density, etc. In this video, I am going to discussing about the theories in coordination chemistry, theories in coordination compounds, we can say. Theories in coordination compounds. To explain the geometry, hybridization and magnetic property, conductivity, color property and stability of the complexes, the following theories was proposed. So generally there are two, we can say it is like two theories. What is two theories means? Earlier theories are there, later theories are there. Earlier theories comes under the Jorgensen-Bloomstud chain theory, we can say. That is first proposed theory. Then Werner's theory, Sidgwick theory. It is also called Sidgwick EAN rule. For later, we can say it is crystal field VBT, valency bond theory, crystal field theory, and MOT, molecular orbital theory, or you can say ligand field theory, LFT. So that I am going to write. Theories are, we are based on two facts, that is what? Earlier theories and later theories. So earlier theories, we can say Jorgensen's Bloomstud theory, you can say Jorgensen theory or Jorgensen-Bloomstud theory. Second one is Werner's theory. Then third one is Sidgwick EAN rule. Sidgwick EAN rule, or you can say Sidgwick theory. EAN means what? Effective atomic number. Later theories are valency bond theory, you can say VBT, crystal field theory, CFT, and ligand field theory, LFT, or you can say molecular orbital theory, MOT. So these are the theories. We will discuss one by one. First theory was proposed, Jorgensen chain theory, you can say Jorgensen-Bloomstud theory. So Jorgensen theory, right? So this is a chain theory, Jorgensen chain theory. According to this theory, ligands are attached to metal in the form of chain. Ligands are bonded to the metal in the form of chain. So generally, for example, if I will take, so like cobalt, examine cobalt, Jorgensen took the examine cobalt chloride complexes. According to this complex, generally he took examine cobalt chloride complexes. This example if I will take, so for example if I will take here, this is what the structure proposed by chain theory is. I will write each all, but just I am explaining how you will write. NH3 here, NH3Cl if you will write. So this is NH3Cl if I will write. So 2 ammonia is finished, so 4 are remaining. So that you can say he proposed the structural arrangement. This is the structural arrangement pattern for this. First you should observe this example, then we will explain all remaining examples likewise. How it is means, if it is the negatively charged ligands, that is Cl minus is the negatively charged ligands is far from the metal. That means far from the metal means it is not directly binded to the metal. So whence the negatively charged ligands is far from the metal, hence those valencies are ionizable. If the negatively charged ligands are directly bonded to the metal, those are non-ionizable valency. So this is a best example you should observe. I will discuss all the facts in this Jorgensen chain theory. According to this theory, ligands are bonded to the metal in the form of the chain, right? So first I am going to write taking COCl3 6NH3 is the example for this, and COCl3 5NH3. Second one COCl3 4NH3, COCl3 3NH3. I will write the structure one by one. First, COCl3 6NH3 already just now we written this NH3Cl. The structure is structural rearrangement for this Jorgensen given in the form of chain. Chain is like this NH3, 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 NH3Cl. And here also NH3Cl. For this structure, he written the structure is like this NH3Cl. This is NH3, 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 Cl. So the third one, this is a Cl. The third one is directly, chlorine is directly bonded to the CO, that is metal. Here this he gave the structure is like this Cl, Cl, NH3, 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 Cl. First I am explaining this structure. So how you will get COCl3 6NH3 means here you will get the chloride, chloride, chloride. So these are far away from the metal, hence this forms the 3 Cl minus, that is 3 ionizable ions, 3 ionizable valency is there. If more number of the ions, more conductivity. Already this concept we discussed in the electrochemistry. The number of ions increases, conductivity increases. Same concept like if number of ions is increases, so that is Cl minus is detaching from the metal. So you can say ionizable valency. So that is 3 Cl minus, it gives the, so number of ions increases, then conductivity is increases. The conclusion is conductivity is increases. Conductivity increases. Now if you will compare this one to this one, here only 2 ionizable valencies are there. One is directly attached to the metal, so that is not going to ionize. So you can say it is non-ionizable valency. Only two chlorides, 2 negatively charged ions only, that is ionizable valency. Hence compared to this, that means you can say 2 Cl minus, right? Here 3 Cl minus. So compared to this, this is the less conductivity. Conductivity is decreases compared to first one. Conductivity is decreases compared to first one. If I talk about this example, COCl3 4NH3, here 2 chloride ions are directly bonded to the metal, hence those are non-ionizable. Only one chloride ion is, so that is ionizable valency. Hence this conductivity is very low because only one chloride ion. So the number of ions decreases, conductivity is decreases. So only one chloride ion. So hence you can say simply this is nothing but the conductivity is less compared to the previous one. So the conductivity is more for this compared to this. This is very less compared to this. This is very less. This is a consider if I took. So for this case, if I took the cobalt chloride Cl3 3NH3 means, so the all chloride should be directly bonded to the metal. Hence the conductivity is 0. So the measured conductivity is 0. There is no accommodation for the further ammonia molecules. Hence this structure was given by Jorgensen in the form of this. So actually the structure should be like this, Cl, 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 and there is no further coordination side for the ammonia. Hence they given the Jorgensen given the structure is like this NH3Cl, NH3Cl. This is the structure given by the Jorgensen. Now you can conclude that this is more ionizable valency. Actually this should be very low, but this according to the Jorgensen theory it is given this is more conductivity compared to this one. Hence the drawbacks for this theory is the structural arrangements and conductivities are not correlate with each other. This is the conclusion. Hence this theory was rejected. Next, second theory is Werner theory. So this is a conclusion. What is the conclusion? The structural arrangements and conductivities are not correlating with each other. Hence this theory was rejected. Next, second theory is Werner's theory. If they will want to ask in the examination, mostly they won't ask from the this much basic. So maybe chances are there according to Jorgensen chain theory. So which of the following is more conductivity? So second theory is Werner's theory, Werner's coordination theory, Werner's theory. According to, so in 1873, Werner proposed a theory for the existing complexes and structural rearrangement. Existing complex and structural rearrangement. So mainly his postulates are two categories. One is he is divided into primary valency and secondary valency. Primary valency and secondary valency. So what is meant by primary valency? What is meant by secondary valency? So in this theory, that is very important concept. Always you should remember, primary valency is nothing but oxidation state. Secondary valency is nothing but coordination number. Primary valence represents the oxidation state. Secondary valency represents the coordination number. This you should by heart. In whatever the complex they given, if they will ask what is the primary valency, that is nothing but oxidation state. That you have to keep in the mind. So primary valency, we will see some points for the primary valency. Primary valency satisfies the negatively charged ions. So nothing but ligands. Primary valency satisfies the negatively charged ligands. So next, this primary valency only represents the oxidation state. This is given with the broken line. So the negatively charged ions are bonding to the metal in the like you can say different directions. You can say that is called non-directional approach. Ligands approach to the metal is negatively charged ligands approach to the metal in the primary valence is non-directional. You can say non-directional. Now if you compare the secondary valency is satisfies negatively charged ligands and also coordination number. So that is nothing but you can say if I will take for example COCl3 6NH3. This is he is also took the example of hexamine cobalt chloride. So for this complex, if I will take like for example octahedral complex, if I will take chloride. Here you should write. This is what ammonia, right? Hexamine, ammonia, NH3. Here you should write NH3. So according to this primary valency, generally we will write like this: Cl, right? If I will write in place of 6NH3 only 5NH3, if I will write, so that time what happens? This chloride is satisfies the primary as well as secondary valency. This line is satisfies this you can say Cl. This chloride is satisfies primary as well as secondary valency. Like this you can say, simple concept is this is represents the coordination number and this is represented with the thick line. Thick line means it is bonded directly to the metal with the strong attraction forces. Hence this is a non-ionizable valency. So you can say it is ionizable valency. Primary valency is nothing but ionizable valency. So this is what non-ionizable valency. This is thick line is represented with the thick line non-ionizable valency. So the thick line means non-ionizable valency. The ligands approach to the metal in the directional way means, so for example if they will attach to the like four are there, like 4 they give the specific structure, like if secondary valency is ligands is 4, it gives the particularly tetrahedral or square plane or whatever it is. Secondary valency is 6, you can expect the structure of octahedral, like this way. So mainly he took the hexamine cobalt chloride, then the structure is octahedral concept. So this is about primary valency and secondary valency. We will see the examples for this, how the molar conductivities are affecting this concept. First example, Werner's theory, COCl3 6NH3. I will explain 2 COCl3 5NH3. Now I will write the structure for this. Here you can say cobalt, here also same structure. Now we should write 6 NH3s are there, NH3, 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 this is also NH3. Here also 5 NH3s are there, NH3, 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 NH3 this one, NH3 this one. This is the 5. So now first COCl3 means this is the 6 coordination number. Primary valence is chloride is like this. You can approach from any way. So this is the primary valency. Same structure if you will take Cl, you will take Cl, but one NH3 is not there. So that is also satisfied by the chloride, hexamine cobalt chloride. Right. Now I will take this structure cobalt NH3 taken try 6. Cobalt NH3 taken try 6, Cl3. So upon hydrolysis what happens? So because 6 NH3s are there, 6 are satisfied by secondary valency, that is coordination number octahedral. 6 is present inside the coordination sphere. So that is CO NH3 taken try 6. So that is outside is Cl3. So upon hydrolysis we will get what? CO NH3 taken tries 6. Already I told you this is Cl3 means you will get here plus 3 Cl minus you will get. So hence this is the one ion. This is completely, this square bracket is represented as one ion. So this is one ion, this is 3 ions, total 4 ions are present. 4 ions conductivity is equal to approximately you can say 430 ohm inverse. 430 ohm inverse. This is the conductivity concept for this. If I will take this concept for COCl3 5NH3, so how the structure is, you will write CONH3 taken twice, 5 is there, so we need 6 means one more chloride inside the coordination sphere, that is satisfies both primary valency as well as secondary valency. So the remaining Cl2, 2 Cls are outside. Upon hydrolysis what you will get? Same CONH3 taken twice 5 Cl. So the charge is plus 2 Cl minus ions, because already I told you this is a 2 Cl minus, this is a plus 2 Cl minus. Total 3 ions are present. That 3 ions conductivity is equal to approximately 270 ohm inverse. 270 ohm inverse. So in generally example they will give which of the following is more conductivity, means if they will give two, this one and this example if they will give this example, they will give out of this is the more number of ions possessed, thence more conductivity is present in this. Next few more examples like COCl3 6NH3 we saw, 5NH3 also we seen. Next is COCl3 4NH3 and 3NH3. 4NH3, this is 3NH3. Like this same, if I will take here cobalt, here also same cobalt octahedral. First write how many amines you want. NH3, 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 4 amines are present. You should write the 4 amines. So the remaining are chloride. What are that? This is the chloride, this is the chloride, satisfies both primary as well as secondary. This is the one more chloride because 3 chlorides are there. So if I will take this one NH3, you can take here, you can take this NH3, you can take one more NH3 here. So you will get, so here chloride, right? If I will write chloride here, this is a chloride, this is a chloride, this is a chloride. This satisfies both primary as well as secondary. Now if I will write the structure for this hydrolysis, upon hydrolysis you will get cobalt NH3 taken twice 4. So inside 2 satisfies the primary and secondary valency. Cl2, outside is one Cl is present. Outside, that is primary valency, ionizable valency. Upon hydrolysis, it gives the cobalt NH3 taken twice 4 Cl2, that is charge is, if Cl is minus, this charge is plus, and Cl minus. 2 ions are present. 2 ions are present. The conductivity is approximately 97 ohm inverse. 97 ohm inverse. If I will take this example, cobalt NH3 taken twice 5 and Cl, here taken twice 3, right? Taken twice 3 and inside also 3 is there. So upon hydrolysis, there is no reaction because no reactions outside the ionic sphere. No compounds are present outside the ionic sphere. Hence, the conductivity is so that is no ions are present. No ions are present. Hence, conductivity is what? Conductivity is, you can say, 0. Conductivity is 0. So this is okay. Generally, they will ask examination point of view like this. They will give this one. Which of the following is more? Which one of the following is a more conductivity nature? More conductivity nature. So what is the drawbacks for this? What is the drawbacks of Werner theory? So the main drawbacks of Werner theory is he only gives the octahedral complexes. He does not explain the tetrahedral complexes or 4 coordinated complexes. He fails to explain the tetra coordinated complexes, and also he doesn't give the geometry and hybridization and color property, magnetic properties, those. Hence this theory was also rejected. Werner's theory was also rejected. In examination point of view, I will discuss some questions like how the examination they will ask the questions. What is the primary valency? What is the primary and secondary valency in the Wilkinson catalyst? That you can say rhodium PPH3 taken twice 3 times. So that is Cl. This is a complex. My question is what is the primary valency and secondary valency? Options is like this. So 4 and 3. Option B 3 and 4. Option C 1 and 4. Option D next 4 and 1. If this is a question, I already told you what is the primary valency and what is the secondary valency. Primary valency is nothing but oxidation state. Secondary valency is nothing but coordination number. So what is the oxidation? PPH3 is neutral ligand, hence oxidation state is 0. So rhodium is rhodium plus, so that is 3 into 0 plus 1 into Cl is minus 1, that is 0. Total charge is 0, already I explained. So rhodium is equal to minus 1 goes that side plus 1. So the oxidation state is plus 1. Oxidation state is plus 1 and coordination number is, this is a 3, this is a 1. So total 4. Option is 1 and 4 is the option. Same question if I will take about the K, PT, PTCl3, so C2H4. G salt, if I will take the G salt. This is the G salt. G is a salt. What is the answer? What is the answer for this? We will calculate. K plus is there, automatically minus is there. So you should only concentrate on this concept. Only you should concentrate on this term. So now you take, what is the oxidation for this? Now what is the oxidation? This is the X plus 3 into chloride is minus 1, 3 into minus 1 plus ethylene is neutral ligand, hence that is 0. So that is value is equal to minus 1. X minus 3 is equal to minus 1. X is equal to minus 1 plus 3. Minus 3 comes here plus 3. X is equal to plus 2. So primary valency is 2 and secondary valency is nothing but coordination number. What is the coordination number for the G salt? Coordination number 3 chlorides are there, 1 ethylene ligand is present, total 4. Secondary valency is 4. This is the one more best example. There may chances in the examination to ask the competitive examination like G salt. And one more example for this. Which of the following is a more conductivity? Like if I gave you K3FeCN6, already the name for this we already discussed. What is that? Potassium hexacyanoferrate. And K4FeCN taken tries 6. This is option 1, 2, 3. 3 is K2HgI4. And fourth one is silver NH3 taken tries 2 Cl. So this is a fourth example. Out of this, which of the following possess the more conductivity nature? Which of the following possesses more conductivity nature? This is 3K plus ions. Outside the sphere is 3K plus ions. So this is automatically minus 3. This is 3 ions. This is completely 1 ion. Total is 4 ions. Here 4K plus ions plus what is this? FeCN taken tries 6. The charge is minus 4. Total is 4 plus this one is ion. 5 ions. This is 5 ions. 4 ions. This is what? 2 plus 1. 3 ions. So this is 1 ion. This is 1 ion. Total is 1 plus 1. 2 ions. Compared to all, only K4FeCN6 is the possess the what? Highest conductivity. Possess the highest conductivity or more conductivity. I am taking this is the question like I am giving the one more question. This is option 1, this is option 2 K3, this is option 3, option 4, 1, 2, 3, 4. Out of this, which of the following does not possess the conductivity? Out of this, which of the following does not possess the conductivity? This is my question. What is the answer? Which does not have the number of ions, which 0 number of ions. So that is the conductivity. Already discussed. This is the 4 number of ions, 3 number of ions, 2 number of ions. That is 0 ions are present. Hence this does not possess the conductivity. This does not possess the conductivity. This is about Werner's theory. Important questions for the competitive exams. Next, Sidgwick theory. Sidgwick theory. In this session, this is the last theory I am going to discuss. Sidgwick EAN rule, you can say. Sidgwick EAN theory. Effective atomic rule, you can say. Sidgwick theory or effective atomic rule. Sidgwick theory or effective atomic rule. According to this theory, the bond between the metal and ligand are coordinate covalent bond. So this is the ligand and lone pair of electrons. So this is the bond between the metal and ligand considered as coordinate covalent bond. Coordinate covalent bond. Coordinate covalent bond. So the symbol, what is meant by EAN? EAN means what is the full form of EAN? Effective atomic number. Effective atomic number. Effective atomic number. So now what is the concept here is this ligand donate a pair of electrons or something. This ligand donates a number of electrons to the metal. Hence the number of metal atoms electrons is increases. Ligand donates a metals to the electrons. Hence metal atom electrons are increases. So now the total number of electrons present in the metal is called the EAN, that is effective atomic rule. The total number of electrons present in the metal is called the effective atomic number. So that is represented with like this. So EAN is equal to total number of electrons present in the metal plus 2 into coordination number, because each ligand donates the 2 electrons. 2 into coordination number means 2 into ligands, we can say 2 into coordination number. So EAN is also represents as total number of metals is what? Z minus oxidation state. Z minus oxidation state plus 2 into coordination number. This is the general formula for to find out the EAN. So what does it mean Z minus oxidation state? Z minus oxidation state means, so if Z means what? For example, atomic number. For example, if I will take iron, what is the iron? Iron is 26. Atomic number is 26. I will write the Z is 26. If iron plus 3 is there, Iron plus 3 means loss of 3 electrons. You will get iron minus plus 3. Oxidation state is what? Plus 3 means you can write 3. 26 minus 3 you will get. So that is what? 23. If iron for example, something like whatever it is, something minus charge is there. For example, minus 1, something, whatever it is there. Minus is there, that time we will add the minus into minus plus. Most cases we will get only plus cases only in the metals. According to this theory, EAN rule is nearer to the inert gas elements. So that is what? So that satisfies the 8. Generally, helium, neon, argon, krypton, xenon, radon. Helium atomic number is 2. Neon atomic number is 10. So 2 plus, actually you should write some periodicity. 288. You should add again 8. So you will get 10, 8 is 18. So 18 again you should add. So you will get 36. 36 again you should add one more 18. You will get the 54. You should now add the 32. You will get the 86. You will get the 86. This is a periodicity called. This is called periodicity in the group. Periodicity in the group. So 8, 18, 18, 32. So 2 plus 8, 10. 10 plus 8, 18. 18, 18, 36. 36, 18, 54. 54 plus 32, 86. This is the periodicity. Now you can say, according to EAN rule, the EAN number is nearer to the inert gases. That is, you can say here 10 or 18 or 36 or 54 or 86. So those are stable. You can say those are stable. So if like I got the 35 value, that is unstable. So this mainly discussing about the stability of the concept. We will see some examples, then we will understand what is the concept involved in this. So first I am going to take the example for this nickel Ni, CO taken twice 4. CO taken 4 times. CO taken 4 times. So now I will write EAN to calculate the EAN. What is the EAN for this? Nickel Z is, what is our concept? This is a complex I am giving. The oxidation state previously we saw, whenever carbonyl is there, you should write 0. So oxidation state of nickel is 0. Now we should write nickel atomic number 28. 28. So minus oxidation state is 0. No need to write 28 plus 2 into 4. 2 into 4 to the, because 4 coordination number is 4. 2 4 is the 8. So 28, 4 to the 8 plus 28 is 36. 36 means stable. 36 is stable. Second example, if I am taking iron CO taken 5 times. So EAN concept is, so this is also oxidation state is 0. EAN, iron is what? Iron is 26. Oxidation state is already 0. Then coordination number is 5 into 2. 5 2s are 10. 10 plus 26, 36. This is also stable according to EAN rule. Otherwise, sometimes they will ask the question like this. They will give the different examples, and which of the following obeys the EAN rule. Which of the following obeys the EAN rule means which of the following this 36, 8, 10, 18, 36, 54, 86 number that is stable. So that obeys the EAN rule. One more example, if I am taking vanadium CO taken 6 times. Vanadium CO taken 6 times. So what is the vanadium oxidation state? Atomic number 23 plus 6 to the coordination number 6 to the 12. 23 plus 12 35. That is unstable. You can say simply it is unstable. This is one more example. Next examples I am going to give. K3FeCN6. Next examples. K3FeCN 6 times and K4FeCN taken 6 times. FeCN 6 times. These are the two examples. And which of the following obeys the EAN rule? Which of the following obeys the EAN rule? This is my question. If I will take, you can also find K2HgI4. We can also take this one, whatever it is we can take. Right, we will see. K3 is there, 3k plus, already I told you whenever 3k plus is there, you should write minus 3. So hence cyanide is the 6, you will get minus 6. Minus 6 comes this side, plus 6 you will get, the charge is iron plus 3. Charge you can say iron plus 3. Here plus 4 is there, here automatically minus 4. This is the minus 6 you will get. Minus 6 comes this side, plus 6. Minus 4 plus 6 you will get iron plus 2. Oxidation state is plus 2. Here 2k plus is there. Automatically you will get minus 2 here. This is the 4 minus means minus 4. Minus 4 comes this plus 4. So minus 2 plus 4 is, you will get mercury is plus 2. So oxidation states now we calculated already in the previous examples also already I calculated. This is the plus 3, iron plus 3, iron plus 2, then mercury plus 2. This is the I am going to calculate. Iron is what? 26 minus 3 electrons loosed. Hence 26 minus 3 is 23 plus 2 into 6 Ligand number, 2 into 6. So now we can say 26 minus 3 is 23 plus 6 to the 12. So that is 35. Hence it does not obey the EAN rule. Hence it is unstable. So now if I will take this one, 26 minus, so what is the plus 2? It loses only 2 electrons. 26 minus 2 plus 2 into 6, you will get what? 26 minus 2 is 24 plus 2 into 6 is 12. So you will get the 36. 36 means it obeys the EAN rule. Right. Mercury atomic number is 80. 80 minus 2, it loses the 2 electrons. 80 minus 2 plus 4 into 2 into 4, because 4 is the coordination number. 80 minus 2 is 78. 4 to the is 8. 78 plus 8 is 86. Hence 86 means it obeys the EAN rule. This 36 is nearer to the krypton. Not nearer, it is exactly 36 is nothing but krypton. 86 is nothing but radon. 54 is nothing but xenon. So that is the Sidgwick EAN rule. Like this way they will ask the questions in the competitive examination. But this theory is also failed because it does not explain the hybridization, geometry and color property of the complexes. Hence this theory is also rejected, and furtherly we will move to the valency bond theory. So generally extension of this topic related to OMC is, so how to calculate the metal bonds and how to find out the 18 electron rule, that we will discuss separate concept, like generally to find out the metal 18 electron rule or metal bonds. To find out the metal bonds, formula is 18 into N minus TEC, total electron count, by 2. This formula we will use. I will do the separate video for this topic because it is not required here. So next video we will discuss about that is what VBT and CFT crystal field. If you like my video, subscribe my channel and share to your friends. Thank you so much.